Again, you know, you play with stuff, sometimes you find things that you just don't even see them coming, you know. Also, if you like VoIP, of course you can manipulate VoIP through VoIP protocols like SIP. But what's really cool is that a lot of these devices, they allow you to perform telephony actions through the HTTP interface. So in the case of the home router, again, we combined the authentication bypass that we found with the request forgery. And if you trick the victim to visit a page, you can make the phone ring. So if you're the victim, right, if you're being fooled, this is what it looks like. Your phone is ringing, right, and it says incoming call. The cool thing is that when you press pick up, you're actually making a phone call. You're actually making a phone call. It's not really incoming call. You're making the phone call, right, to a phone number that has been chosen by the attacker, you know. So I don't know. You could make the phone, I don't know, call the Vatican or, you know, any random phone. Perhaps, you know, in the world of toll fraud, telephone toll fraud, a very common trick for criminals is to register a premium phone number and then use the victim's premises to dial that number, you know. That's how they profit, you know. If you have a PBX in your company, right, and it gets compromised and they're rerouting calls to a premium number, they're going to make some good money that way, you know. This is the same story. Another good example in Snomp phones, it's a German company, quite popular in Europe. Mario from GNU Citizen, he found similar vulnerability, but actually more serious in my opinion, because you could make the phone be picked up automatically without the victim really knowing that it's happened. So you're in your office, you have a Snomp phone, and if someone can talk to the HTTP server, which, you know, it might not be available on the internet, but it could be a fellow employee, one of your colleagues, right? So they can make the phone be picked up. You don't even know. Your phone is there, you're talking, and the attacker is listening to your calls. You know, it's just an example of cool things that you can do, you know. It's an eavesdropping attack, obviously. So I've been researching the idea of combining HTTP and other protocols to combine an attack. You know, usually we all stick to the same technology. So if you want to do a web attack, you talk in HTTP, but sometimes you can combine both. Now, with this attack, I'll tell you the counter argument and the pro argument, right? The idea is, if you have compromised a device via SNMP, so you have cracked the SNMP write community string, right? Usually, you know, if you're a penetration tester, you'll say, it's a high-risk issue, level 4, level 5, game over. In reality, it's not necessarily game over. Sometimes you find that some devices, depending on the implementation, will only allow you to change certain OIDs in SNMP terminology. So only certain objects. So that might mean that even if you have cracked the SNMP write community string, all you can do maybe is change the system name, the contact name, not something that will allow you to fully compromise the device. So if you're stuck in that situation, right, what you can do is use one of those objects that you think that are not a big deal, right, and change it and put a HTML or JavaScript payload. So a common example, if you look at these 3 different OIDs, so we have contact name and location. These are 3 different OIDs that are very commonly printed on the web interface. Remember, you have write access through SNMP, but you're limited. You can only change certain OIDs. Now you need to sneak your payload through SNMP on the web console. So next time the administrator logs in, boom, you compromise the device, right? So that's the idea. So you can think of it as a privilege escalation attack, really. Cisco routers, most of the Cisco routers are vulnerable to this. Again, remember that you need to find the SNMP write community string. But you can go from a restricted situation to a full compromise. It's been confirmed by Cisco, right? They checked it. It works on most of the devices. The reason for that is because the Cisco iOS HTTP server prints the system name in virtually all pages. If you have a Cisco router, just notice that you usually have the system name printed on the top left corner, I think, of the web interface. So if you change the system name and you put a malicious payload, there's a really, really high chance that the payload will be triggered, provided that the administrator logs in on the web console, because it's printed on every single page, you know. So this is just a screenshot. It's cropped, obviously, you don't have everything else. So what's wrong with this picture? Well, there's an image on the top left corner. That image is actually it's not a real image. It's just an image tag which makes the browser submit a HTTP request to the router, which changes the password. Now, there's a way to inject an image without showing, right? You can use JavaScript and dynamically generate an image. So please don't think that if something is injected, it will be obvious, because you can make it completely invisible. I use this method because it's better to illustrate that there's something being injected. This is the HTTP request that it's actually sent in the background. So it's basically changing the enabled password. So again, at that point, the attacker can log in with that password because it's being changed. This is command execution, okay? It's really, for me, I think it's quite cool. It's been confirmed by Cisco, and as a researcher, there's nothing more gratifying than someone finding your research interesting. So the Cisco PSIRT team, they said, we read your paper and we found it interesting. It is by far the most creative approach we've seen so far for an XSS attack against the iOS HTTP server component. I thought it wasn't that cool. They liked it a lot, so it helped me boost my ego, and then I'm back to reality. Go back to work, keep doing your boring stuff. That was the highlights of the day. Someone liked something that you've done. Whoa, cool. Okay. Now, firewalls are there to protect you, but in security research, we know that security mechanisms sometimes actually introduce security problems. We see in the world of antivirus all the time. There's so many guys exploiting the drivers, right? Because the antivirus runs with system privileges. You know that if you exploit it, it's game over. Not only your administrator, your system, it's even better, That's because the antivirus runs with those privileges, obviously. I was playing with Sonic Wall firewalls, right? And if you work for a big company, right? If you work for a big company, you'll see that they usually have content filtering. And that's really annoying because it means that you might not be able to check your personal webmail. Most importantly, you cannot browse porn on the internet and all this kind of annoying stuff, right? Now, what's really funny is that it turns out that you can exploit the content filtering service to hijack any website. So I'm going to go through the example, right? So say Sonic Wall, right? Firewalls, like many other firewalls, they allow administrators to block pages by category. So the service will update on a regular basis, and it will say, okay, this is the updated database for hacking sites. This is the updated database for pornographic sites, right? But it will also allow you to block sites based on keywords. So if you go to Google and you search for, I don't know, choose your favorite swear word, the URL will, the HTTP request will have the keyword, and the content filtering service will say, hey, this is a bad word, not allowed. Well, this is the actual feature precisely that I'm exploiting in Sonic Wall. So you get a page. I will show you actually. You get a page, right? And it says, sorry, this page has been blocked by the content filtering system. Now, notice the following. This is very, very important to understand the implications, the security implications. If you look at the address bar, it says google.com. In reality, google.com has not replied to my HTTP request. It's the firewall. The firewall is sitting between you and the internet, right? Now, this is really funny because usually when you're compromised, it's because there's either a problem on your side, so the client endpoint, so there's a vulnerability on your browser or browser plugin, operating system, or maybe there's a vulnerability on the server that you're connecting to. Imagine, maybe you're going to YouTube, right? YouTube is a bad example, okay? But let's say that someone compromises a website that you use often, right? The attacker has exploited a vulnerability on the server. In this case, it's something in between. It's not you, it's not either endpoint, it's not the user, it's not the site you're connecting to. You have an intermediate appliance, a hub in between, right? And that appliance is there to protect you, but actually it's not, it's allowing the attacker to hijack any domain. So what's important is, if you look at the URL on the top, we have a swear word, it says fuck. I'm sorry to have to include a swear word, but I had to because it's the only way to make this work, right? So excuse my language, sorry. I wanted to blur it, but then if you blur it, then people don't know why it works, It works because it's a keyword that's under swear words and it's been blocked. Google.com, because that's the URL that has been requested. And then you have basically the scripting code that runs within the context of google.com. That's the most important bit. So it means that, you know, as any cross-domain vulnerability, you can hijack anything from that domain. You can scrape any page, perhaps your address book of Gmail. You can, I don't know, steal your cookie. You can inject fake HTML. And if you're into cross-scripting, it's DOM-based cross-scripting, which is perhaps the most misunderstood type of cross-scripting. Amit Klein wrote a paper a few years ago, and he clearly said, I have not come up with this vector, but I'm making a distinction between regular XSS, persistent XSS, and this third type. And he's quite right. You know, there's a distinction. Typically, when you have XSS, the payload is being returned by the server. So you have a specially crafted payload, you inject it, and the server returns it back. In this case, it's not going to work. So if you're running your favorite vulnerability scanner, most likely it's not going to pick it up because the error page is not returning the payload. It's using DOM functions. In this case, it's using document.write. And if you notice on the very top, what's really actually writing is document.url. That's basically the URL in the address bar of the browser. You have full control over that. So put it this way, if you have a Sonic Wall firewall in your company, and you have content filtering service enabled, most likely if any of your employees is tricked to visit a page, you know, any website on the internet can be scraped. You know, any of your personal data can be stolen or cookies. It's been confirmed by Sonic Wall. I submitted the vulnerability through ZDI, and it was quite cool because zero-day initiative usually is more about memory corruption bugs, you know, and this didn't fit into that category. It wasn't a heap overflow or something like that. But they thought that the vulnerability is quite weird, so it's, you know, they thought, yeah, it's cool. We like it, you know, we're interested in it. And for some, in some browsers, if you put the payload after, you know, directly in the URL without doing anything tricky, it won't execute it. In the case of Internet Explorer, you need to put it after the hash sign. Otherwise, the payload won't execute. So it could be tricky to make it work on all browsers, but I proved that I could make it work on IE 6 and 7, which are pretty much the most popular browsers. So that's enough for me, you know. And you know, the whole idea is, you know, we know about vulnerability types, but sometimes there are weird ways. You know, these vulnerabilities can be found in interesting services. You know, in this case, so far I haven't seen a vulnerability on a firewall error page that allows you to hijack any domain. You know, it's kind of like similar to the Adobe Reader Universal XSS, but actually in this case the vulnerability is beyond your control because you don't have control over the firewall. Updating your operating system is not going to help you. Updating Internet Explorer is not going to help you. The only thing that's going to help you is having a non-vulnerable firewall, you know. And again, going back to home routers, a lot of home routers now, they come with encryption enabled by default, you know. But it turns out that many of these default encryption keys, they're predictable, you know. So if you buy a home router and it comes with whatever encryption type, you know, the WPA, whatever it is, just change the default key because there's been already like quite a few examples, you know, at least 4 examples as in May 2008. So, and actually I've seen at least two other examples. There's been a lot of examples in which, you know, people have figured out that actually the keys, they're predictable, you know, and usually they're derived from either the SSID or the MAC address of the access point, which are both public information, even if the network is encrypted, you know. Even if you disable SSID broadcasting, all the clients, all the stations are going to send a probe request, you know, so the clients are leaking that information anyways. You cannot hide the SSID, you know. MAC address, same thing. Even if there's encryption, you're still going to be able to get the MAC address. That's not encrypted. So quite cool stuff. That was published by Kevin Devin. He likes playing with, you know, reverse engineering and all this kind of stuff. But he was really clever, in my opinion. He did a really, really clever, he approached the problem in a clever way. So let's say that you want to find the algorithm to generate the default key, right? What most people do is that they go for the router itself, you know. They try to do remote debugging through GDB, you know. They try to dissect the firmware. But this guy was more clever, man, because what he did is he, first of all, found another ISP in Europe using a similar router because the BT Home Hub, it's actually a Thomson speed touch router. It turns out that in Spain, Orange would provide a CD with the speed touch routers. And this CD